In this problem, we have the angular velocity of the real wheel of a stationary exercise bike is 4 radians per second at time equals 0. Then it says that its angular acceleration is constant and equal to 2 radians per second squared. Next, at a particular spoke coincides with the x-axis at time t equals 0. The question is, what angle does this spoke make with the x-axis at time t equals 3 seconds? And lastly, what is the wheel's angular velocity at this time? So first, we drew everything that's being said in the question so we can easily plug in into whatever formula we're going to use. Now there's a formula to find the angle that this spoke make with the axis at time equal 3 seconds. That's going to be the initial angle plus the initial angular velocity times time plus 1/2 the angular acceleration times time squared. Now according to the graph, the initial angle is going to be equal 0 and the initial angular velocity is going to be 4 radians per second, and the time given is just 3 seconds. So we just plug it in into the equation. We also add it up to the 1/2 times the angular acceleration, which is also given, is going to be 2 radians per second squared times the time, 3 seconds, also squared. And that should give us the value for theta being equal to 21 radians. But to convert it to degrees, we just have to do a little conversion. We got 21 radians divided by 2 pi radians, which is the same thing as 1 revolution, so we can cancel out the units. And that should give us 3.34 revolutions, or nearly 122 degrees. Now for the last part, to find the wheel's angular velocity at time equals 3 seconds, we have to use the equation angular velocity equals the initial angular velocity plus the acceleration times the time. So as we plug in the values into the equation, we have 4 radians per second plus 2 radians per second squared times the 3 seconds, and that should give us exactly 10 radians per second as our angular velocity. Acceleration